So here I have drawn a very simple ladder diagram. The ladder diagram shows how things are connected electrically. So in this diagram we see that we have L1 feeding power to one side of the loads and L2 on the other side of the loads. In this particular example we have a power supply of 230 volts. On the first line we have the compressor, and it is controlled by the C, or the contactor coils. When the coil of the contactor is energized, the compressor will run as these contacts will close. On the second line we have the indoor fan motor. It is controlled by a set of contacts that when energized, our indoor fan motor will run. On the third line, our outdoor fan motor is controlled by a CR set of contacts and a DFR relay. This is so that the fan will operate whenever the compressor is running, and it will also be brought on and off during the defrost cycle on a heat pump. On this line we have a crankcase heater. It is controlled by a set of contacts that when the compressor is not running, these contacts will be closed, and as long as our temperature switch is below 65 degrees, our crankcase heater will operate. We then have our transformer that is powered on the one side by the 230 volts, and it steps down the power supply to 24 volts for our control circuit. In our control circuit we have the Y circuit, which is the contactor for the compressor operation, and we also have pressure switches in this line which would either open or close on low or high pressure. Here we have the indoor fan relay on our blower or G circuit, that when this is energized, the indoor fan motor will run. We also have here the reversing valve circuit, which is our O circuit, that when this line is energized, the reversing valve will switch and either put us in cooling or heating depending on what the energized cycle does. It is very important for a service technician to be able to read a wiring diagram. This is a standard wiring diagram with the schematic or the ladder form on the right hand side, which, as we just saw, shows the loads on the line that they are together with. You also have the connection wiring diagram, which shows wire for wire where each wire is landed on each component. This can be very important when tracking down shorts or a miswire situation in a unit to find out where each wire is located. Many times when technicians replace parts, wires may get misplaced, which causes the unit not to function. So it's very important to follow the connection diagram and make sure that every wire has been landed where it should be. Also, there's a legend on a wiring diagram that will tell you what is factory wiring, what's field wiring, and what many of the components are on the wiring diagram. There are also notes which are important for installers and service technicians doing work on this unit. So pay particular attention to the legend and to the notes on wiring diagrams. All of your electrical wiring diagrams have a legend which will tell you what's going on in the wiring diagram. On this particular legend you'll see that it outlines what the factory wiring is and what field control wiring or power wiring is going to be. It also points out if there's any LEDs or lights on the control boards. And it points out the various components: crankcase heater, the compressor, compressor switches, and safety switches. And then it also points out if you have a start capacitor, start relay, or start thermistor. So a legend will tell you quite a bit about all the components and the wiring of the unit that you're working on. Also in the diagram you're going to have various notes that give you some information about the components in the system. Notes will be like the compressor and the fan motor has inherent thermal protection. So if the compressor or the fan motor does not run, you need to check out and make sure that it's not off on a thermal overload before you condemn a bad compressor or bad fan motor. It also gives you wiring considerations, the size of wire that is needed for this unit. Tells you that the service valves must be opened before operation, that you should check all electrical connections for tightness before operating the system, that you should not rapid cycle the compressor, and this particular unit has what is called a tech assist operation, which gives you various fault codes for various faults on the system. So the notes will give you some very important information that is necessary for troubleshooting or properly operating the system. So another diagram that is very important for the technician in the field is the component arrangement diagram, which shows where electrical components are physically located in the unit. In this particular example, we're pointing out the limit switch number 2, which is connected to the heater number 2. And so if you are looking for this particular switch in the unit and can't find it, the component arrangement diagram will show you where it is physically in the unit. There are many kinds of symbols that are used in wiring diagrams, and let's just look at a couple to familiarize you with the types of symbols that are used in wiring diagrams. This one is a pressure switch, and this designates a pressure symbol. And this also shows you that this pressure switch will close on pressure rise because the line is below the dot on the right-hand side. And so when the pressure rises in the system, this switch will close and make the electrical circuit. The symbol shown here is a temperature symbol and designates the temperature rise on a switch. Again, the line is below the circle on the right, so when the temperature would rise, this switch would make contact and would close the electrical circuit. As we said, these various switches can be configured in different ways. This switch on the top is a heating thermostat, which opens on temperature rise. The second diagram is a cooling thermostat, which opens on a drop in temperature. The third is a limit switch that opens on rise in temperature. The fourth is a pressure switch, which opens on rise in pressure. And the last one is a pressure switch, which opens with a drop in pressure. This is a current diagram of a unit that has a control circuit board in it. You have your connection diagram on the left that shows where all the wires are landed that we have talked about before. And on the right is the ladder diagram, which shows how everything is connected electrically. You'll also notice that a lot of things are just inputs and outputs of the circuit board, which all of your logic and commands comes from the circuit board. Down at the bottom, you have some dip switch settings, and you also have your note that is available on the diagram. This is a diagram of a current inverter product. And again, you'll notice that you have your circuit board and all of your components, your safety switches, reversing valve, various things plugs into the circuit board. Your transformer plugs into the circuit board, your EXVs. So everything plugs into the circuit board and is controlled by the circuit board. Then of course you have your VFD board and your outdoor fan motor, and your compressor is plugged into the VFD board and is operated off of that. You have some information regarding model plugs on the wiring diagram. You have information regarding the fuses. You have your legend that talks about all the components. You have your notes, which give you various wiring and other considerations. And then you also have a little bit of a unit operation explanation here at the bottom that tells you how the defrost time works and how the defrost is initiated and concludes. And it also talks a little bit about the pressure transducers. So a lot of information on the current wiring diagrams, and it is very important that you as a technician are able to properly read and interpret these diagrams to help in your troubleshooting of the system.
Go to arefco.com for more videos. Like, subscribe, and check back every week for new videos.